If you are using steam in your production line, if you wonder whether your operating costs are silently leaking away, if you want to cut unnecessary expenses in your factory, then this video is for you. Today's topic: steam and 5 common mistakes in factories. Welcome to DIVI Group. Over the years, I've had the privilege to gain hands-on experience in many factories and access key technical materials in the field of industrial steam. Back in my student days, I had a memorable experience. I had to retake heat transfer 8 times despite studying diligently. But that challenge shaped my logical mindset in thermodynamics, which has been invaluable in solving production issues. A clear proof is the $100,000 award from USAID for DIVI's energy-saving technology, born from those real-world experiences. Today, I'll share those insights with you in this video. Of course, we can't cover everything, but I'll focus on the 5 most common mistakes, errors that silently drain production costs without notice. Mistake number 1, taking steam from the wrong position, letting condensate enter the machine. In many factories, the steam takeoff point is placed under the main steam line. As a result, both steam and condensate flow into the machine, reducing heat transfer efficiency. By principle, the steam outlet should be on top of the pipe, ensuring only dry steam enters the machine. Condensate must be separated through a steam trap at the end of the line and returned to the boiler. This is a mistake many factories make, leading to reduced productivity. In textile factories, condensate mixing with steam can stain fabric, cause color bleeding, and damage quality. The visible losses may not appear immediately, but the hidden damage is enormous. Imagine if your production line loses just 5% in capacity, what would that cost? Mistake number 2, poor quality steam traps, hidden heat loss. Many factory owners ask, how much energy does a steam trap waste? If replaced with a good one, how long to recover the cost? In reality, no one, not even the top global manufacturers, can calculate it with absolute precision. But we can picture it simply. The job of a steam trap is to hold steam back and only discharge condensate. But what if both steam and condensate escape together? Many steam traps today are leaking both steam and condensate simultaneously, when in fact, steam should only exit after releasing its heat and condensing into water. If steam traps fail to retain steam, the machine requires much more supply. The lost steam is practically unrecoverable. From my experience, replacing poor quality steam traps with good ones pays back in just 3 to 6 months. To know which steam traps are field proven, contact us via the link below this video. Mistake number 3, returning condensate to an open tank before pumping it back to the boiler. Let's say the supply steam pressure is 8 bar, chucked at 175 degrees Celsius. After passing through the equipment, the condensate remains at about 4 bar, thus 150 degrees Celsius. If this condensate is returned to an open tank at atmospheric pressure, the temperature will drop to around 100 degrees Celsius, and the rest will flash off into the air. That means money is literally evaporating with the steam every single day. There are 2 main reasons for this loss. First, a poorly performing steam trap allows steam to escape, leaving insufficient cooling water to fully condense it. To condense 1 kilogram of steam requires about 10 liters of cooling water, something nearly impossible without a proper integrated solution. Second, when pressure drops from high to atmospheric, the condensate generates flash steam, which further increases losses. So what's the solution? Keep the condensate under pressure and pump it directly back to the boiler instead of sending it to an open tank. This way, it retains 150 degrees Celsius instead of dropping to just 100 degrees Celsius. This is exactly the solution DIVI has successfully implemented in many factories, earning a $100,000 award from USAID. This solution saves 10% to 30% of steam production costs, with a payback period of less than 6 months. Mistake number 4, not installing a check valve in the steam trap assembly. A proper steam trap assembly must include 3 isolation valves, 1 steam trap, 1 check valve, and if possible, a sight glass. Many factories don't fully understand the role of the check valve, so they often skip it. Even many installers aren't entirely sure of its purpose. And what's the result? Condensate from one machine can be pushed back into another, causing unstable outlet temperatures. With a check valve in place, this problem is prevented, ensuring each machine operates steadily with consistent productivity. A mistake that seems small, but ends up costing heavily in operation, maintenance, and overall system efficiency. Mistake number 5, not insulating heat radiating surfaces. In some cases, a pipeline or flange was insulated, but after maintenance, the insulation was forgotten. Many people think it's just a small gap, it won't matter. But reality says otherwise. A single pair of exposed flanges is equivalent to 1 meter of uninsulated pipe. For example, 1 meter of F114 pipe without insulation wastes 0.34 kilograms of wood chip fuel per hour. That means 10 meters waste 3.4 kilograms per hour, while 100 meters waste 34 kilograms per hour. At 24 hours a day, 6,500 hours a year, just 10 pairs of uninsulated flanges waste up to 22.1 tons of fuel annually. That's literally a truckload of fuel vanishing into thin air without you even noticing. The solution is simple. Properly insulate steam and condensate return lines. Use specialized insulation jackets for flanges and valves. They're inexpensive and pay for themselves quickly. I've just shared with you 5 common mistakes in operating industrial steam systems. And don't forget to hit like, share, and subscribe so you won't miss future videos on common mistakes. Thank you so much for watching.